Hello everyone. In this video I'm going to tell you about my own messenger droplet security system. Maybe maybe it's not right to post something like this on the YouTube, but I think it will help me to find some vulnerabilities. So let's imagine we have and and never mind that the whiteboard just is laying this way. I just don't want to reel my wall, at least so far. Okay, let's imagine we have a server and it runs our main API, which has a database connection. In my case, it's a MySQL database, and we also have a signal service. And it also has its own DB database. Okay, then imagine we have Mark and Peter, and Mark is very happy and he's pretty cool and registers in droplet. So he calls the register event, reg-e for short. Register event sends an HTTP request to, here it is, to the main API. And then main API creates a new database record, which has a lot of different variables, but we need two of them so far. Okay, main API creates record and then it sends another HTTP request to the signal service. Signal API actually. And what happens? Main API creates secret. It is just a random string. And this one will be used for 2FA applications. 2FA authorization in apps like Google Authenticator, Authify, or Authai, yes, and different apps like this. Okay, then Signal API creates a lot of fields for Signal protocol. Not actually protocol from Signal Messenger. I've changed it a little bit, but let's still call it Signal protocol. Okay, and I'm going to explain it just a little bit later. Just wait. Okay, Signal API creates public public key, private key, and a bunch of signed prekeys. Signed prekeys. So then Mark has to log in into his new account. So he calls the login event, login E. Yeah, and during login event, user connects droplet account to his 2FA app and actually signed prekeys uh, are being created during this event. Okay. So then let's talk about main API. It has a lot of endpoints, but we will talk about pattern endpoints pattern. Some of them have the auth prefix, and some of them doesn't. Like register endpoint doesn't have the auth prefix, but login. Okay, and all auth requests contains inside the headers contains the authorization header. I hope I wrote it right because I'm not really good at writing in English. Okay, authorization header is basically a base 64 string, base 64 encoded string. And if you will encode it, you will see something like this. And before I will continue, before I'll continue, I forgot tell you about access token and refresh token. And access and refresh tokens are being created during login event. And access token is being used for authorization inside interceptor because actually main API has an interceptor which checks every request, and if its URL contains the auth prefix, then interceptor auth user. Pretty simple. Okay, so if you know what basic authorization means and how it works, then you just noticed that it's it's actually an basic authorization string. But in our application, in our basic authorization string, we don't use password inside authorization. It's weird. We use access token, not not password. Then okay, that's all about authorization. Let's talk about WebSocket. We have WebSocket on our main API, and every single client connects exactly to this WebSocket. Then Mark, after he connects to the WebSocket, he can receive new messages, send new messages, get any information about chats, any information about users. So all the manipulation, all the mm, calculating, all the information about users, chats, and stuff like that exactly is being done exactly WebSocket. This WebSocket. Okay, then let's talk about talking. Let me check. Yeah, our access token resets every 30 seconds. So Mark every Mark's client actually front end resets access token using refresh token every 30 seconds. But here we have a problem. What if Peter uses the Mark's account for some purpose? So he also resets access token every 30 seconds. And when Peter resets the token, after that, Mark will has already expired token. It's not good. It's pretty bad. How we can fix this? When Mark resets token, our main API, our WebSocket, will send a response to all users. Which are authorized in Mark's account. So Mark resets token, Peter and Mark receives some response from WebSocket, and Peter won't reset token again. Here we go. That's all about tokens. I'm I'm not going to I'm not going to explain basic WebSocket security like authorization on connection. What else? Also, you you can't subscribe to the events which you're not allowed to subscribe. So you can't receive any messages from some chat which you don't have, and some more security tricks, but I actually I don't remember all of them, but I think you understand me. Okay, then let's talk about signal protocol. I will explain the general concept of signal protocol. Actually, it's a lot harder. It's really hard to implement it. But I don't have I don't want to spend a lot of time to explain it. Just just let's talk about it in general. Okay, signal protocol. We have Peter, we have Mark. Peter and Mark have a public key, private key, and a bunch of signed pre-keys. So let's imagine Peter Peter wants to message Mark. So using Signal API, he receives from Mark his public key and public part of signed pre-keys. Actually, public part of only one signed pre-key. Actually, every single signed pre-key has its public part and private part, and Peter will receive only public part. Then, using this stuff, he will encrypt message. two times in a row using private key and using signed pre-key. And then he will send the encrypted message to the main API and save it. And that's all. Eh, I'm just thinking what I'm just thinking what can I say more, but I think I think actually that's all. Just okay. Then let's talk about one more security trick. And as I said earlier, it's not, it's not that simple. Um, Signal protocol a very hard stuff, really. It's not just two keys, do something, and poof, we have encrypted message. No, it doesn't work this way. But in general, basically, yep, it works like this. Okay, one more security trick in my application is IP check inside authorization. So let's imagine Peter has a password and login. Mark's password and login. And even if it's correct, he has another IP. And I have to notice that not client sends its IP inside request, inside body. Of course not. Backend receives IP from the request. Actually, I don't know how, but somehow it on hardware level receives it. Okay, even if he has correct password and correct login, he couldn't log in the Mark's account because he has another IP. And it's pretty interesting that every single token access and refresh token also has an IP. So for each IP, there will be an access and an refresh token. And if Peter will attack, for example, using man in the middle attack, Mark, I've I've just forgot his name, Mark. If Peter will attack will perform man-in-the-middle attack, and of course he will receive public excuse me, access and refresh token. Of course, it's not that hard. Nah, it's hard, but in our example it's not that hard. Okay, Peter has a password, login, refresh token, access token, and 30 seconds to use access token. Um, actually, no, because he also has the refresh token. He can refresh access token using refresh token, and refresh token refreshes uh, access token. So he can get account control. And by the way, refresh token is being refreshed once in month, I think. But as I said earlier, every token has IP. So even if access and the refresh token are correct, Peter has another IP. And that's all. He just couldn't enter the Mark's account. So it's possible to log in into Mark's account only using Mark's IP. Only using Mark's IP, only using Mark's PC or phone, or mm, Peter will need to connect to the Mark's Wi-Fi, disconnect Mark from his network, and then using Mark's old IP, logging into his account. And at least it sounds like impossible. Actually, it's possible, but come on, it's it's very hard to do this. And I think that's all. So we have we have two types of tokens. Access token is being refreshed every 30 seconds. We have signal protocol for message sending and receiving. Uh, it's not the real signal protocol, because in signal protocol you're supposed to use your tokens on local device. Yeah, you're supposed to save all that security, private stuff on your local device. But in Droplet, it sends to the Signal API. Okay, we have Signal Protocol, tokens, um, and IP authorization. And it blows my mind. It's crazy. It's crazy that it works. And yeah, I think that is all what I wanted to tell you about. Yeah, I think that's all. So, thank you for watching, and if you if you know a lot in application security, if you know a lot in application security, then please just realize, eh, just compute in your head, just visualize in your head all these security tricks, all these security barriers, and try to find some vulnerability. It will really help me. And write it down in the comments. Yep, I think that's all. Thank you for watching.